So for this one right here, we got this block of clay to work with right here. And to find the volume of a rectangle like that, it's just length times width times height. So we're going to take our 6 inches, multiply it by our 4 inches, and multiply that by the 2 inches. So altogether, that's going to give us 6 times 4 is 24 times 2 is 48 cubic inches. So we want to know then if we make it into a ball, a sphere, how big is that sphere going to be? So the bottom line is how much clay do we have to work with? So that is the volume, whether we call it a ball or a volume, whether we call it a ball or a block, a brick like that. So we just take our formula right there and set it equal to 48. So 4/3 pi r cubed has to equal 48 because that's how much clay we have to work with. And so then from there, you just got to try and solve for r. Okay, so I'm going to leave it at that right now, and then I'll come check on you in a little bit because I did this one for everyone else the other day. But that's the initial setup on that one. All right, so the last lesson is essentially a review of just about everything we've done, even including last term. And it's all about solving equations. So we're going to take every kind of equation that we've tried to solve all term, all in one spot here. So I'll warm you up with one of them, and then I'm just going to set you through the work, and you can check with your neighbors, you check with me when you get stuck on it. So let's go back home here. Don't forget, get me exam corrections soon. Oh, Robert, you can have yours back. And Aaron, I have yours. I didn't finish them yet. I gave you this as Robert, right? Thank you. Making sure I gave it to the right person. All right, so let's check out 4/7. And so we've got today, tomorrow, and the next day to go over 4/7 and to get ready for the final. And final is Monday at 8 a.m. I know. I don't know. So the final exam schedule is designed for 2 things. So there's no conflicts with other classes if everybody goes to their appointed time. And 2, classes that tend to be bigger tend to be earlier in the week. And so apparently this time frame, there's usually bigger classes. So those teachers get first shot at getting their exams graded. So if you can't handle 7 to 8 o'clock, I happen to be free at 10 to. This room won't be free though. There's going to be another class in here because of the way the exam schedule works. So I'll be ready for you at 8. Come at 8 if you can. If you're a wee bit tired still and not ready to come in at 10, that's fine too. And then Daisy, you can take it anytime Monday you want. I will send it to the Hermiston Center. And it'll be on paper, and you can use a spreadsheet, and you can use all of your worksheets, just like the midterm.
Okay.
What's that?
105 you're not teaching.
I am not teaching 105. Greg Schulberg is teaching that. And that is, Daisy, that's also available with a video broadcast too?
I think it's available.
It is available completely on line 2. Yeah. Yeah. Yeah, they have 3 versions, but they're all really the same class. Yeah, so whether you're taking it, so kind of like Daisy is in Hermiston taking this, he'll have the same setup. You can either watch it live or watch the videos. You take it online, you can still go to the classroom. Yeah. Yeah, but that's a class you definitely want to go to if you can, live, so you can ask questions. It's a lot like this. It's all the hands-on stuff. The biggest difference is it's kind of sort of similarly set up. You get, like in here, we have 3 assignments per week, and there you have 3 assignments per week. But instead of a prep and then the worksheet kind of thing, the worksheets are bigger, and the problems, it's more like a textbook that you read with example problems already worked out. And so your first assignment is always to read through the textbook and then try the online homework. That's kind of like the prep stuff. And then there's a quiz, which is just like the homework. It's online, but it's timed. You only have an hour to do it, and you only get one shot at it. Okay. So the trick is, go to class all week, get your homework done. Once you feel comfortable, based on questions in class and doing the homework, then sit down and take the quiz. And it'll be problems just like the homework. And then there's usually a written assignment. So kind of like we have our written assignments here. They tend to be online instead of on paper, though. So you'll have something to type in on the computer, solutions to an equation.
The quizzes are probably a big part, right?
What's that?
The quizzes are probably a big part.
I think homework, quizzes, tests, and written stuff is all about the same. It's all like equally distributed, if I remember right. Yeah. And like this class, there's only a midterm and a final. So there's not a lot of tests. It's mostly homework kind of stuff. Yeah. And, you can, while you're taking the quiz, you can look at your printed textbook, right? So you've got example problems you can refer back to that are similar to the ones on the computer. But the trick is you got to be quick. You can't spend all day on it. You can't start it today and finish it tomorrow. Once you click start, that timer starts running. And even if you close it, it's still running. So if you try to go back into the quiz tomorrow, it'll say, sorry, time's up. Okay, so you just want to be careful about that. But, and Greg Schulberg's a great teacher. You'll like him. And then I've taught it many times before. So if you ever get stuck, feel free to come see me for help too. But he's pretty available for help. But it's a lot like this. So if you're doing well in this class, you'll do fine in 105. Just can't slack off on your homework. You got to do it. That one has weekly due dates. Whereas here, I've been kind of loose about the due dates. That class is not loose about the due dates. You got to get things done each week. So usually Sunday is the cutoff for that class. Okay. What's that?
Anything else to keep up with?
Yeah. All right, let's take a look at mixed equation. So it's called mixed equation just because there's a bunch of different kinds of equations we solve. So like this one right here, what kind of equation is this right here? Of all the different kinds we've looked at in the last two terms, how would you classify that based on where that x is? Exponential, yeah, that's an exponential equation. Yeah, so we'd say, yeah, it's an exponential equation, and then we'll try and solve it. So I'll come back and do that in a minute. How about this one? If there's a square on the x, what's that one called? Talked about that last term a little bit. We just started working on them again yesterday or the day before. Starts with a Q? Quadratic. Yes, that is a quadratic. Anybody remember why it's called quad? It's got four sides. So think about how would you read this right here? How would you read it? Just read it to me. What does it say? 10x squared. Literally a square. How many sides does a square have? Four sides, hence quad for quadratic. Yeah.
Are those ones like
If you graph them, you get that U shape,
yeah.
Correct? Yeah.
Like
Yeah, parabola. Mm-hmm. Exactly. How about this one right here? What kind is that? What's that? Linear. Yeah, you named it. Yeah, okay. So there's slightly different techniques for solving linear, quadratic, and exponential functions, but the basic part is always the same, kind of unwrapping it. So let's do these three together, and then I'll set you guys free to work. So I'm going to copy this first one to my screen.
This is kind of like the practice exam.
There is a practice final up there. Yeah, it's already up there. Yeah, Daisy was asking about it, and I had an error in the way I'd set it up, but I fixed it. So yeah, it's sitting there ready to go. So it's online. It's a lot like the real one, except the real one will be on paper. Do you get to pick ones to skip? Did we do that last term?
Yeah.
I let you skip a few. I'll think about that. Let me make a note.
Let's skip you.
Like we emailed you, like which one do you want me to take?
Oh, I see what you said. Yeah, you guys we did that voting. You voted things off the test. Let's come back to that at the end of class. So somebody remind me. We talked about the final.
Is it 20 questions?
No, no, no. There's no way you could do 20 questions in 2 hours. It'll have to be shorter.
And that's 7 questions.
7 questions might be a bit too short. I think I'm aiming at like 10
It was 8
questions.
last time. Just the right size. I wasn't here.
I could do that.
You do 9. Okay, we'll see. All right, so let's see. Okay, let's get focused on some problems and we'll talk about the final at the end of class. So we've already decided that this is an exponential function because the x is in the exponent position. So the family is exponential. First part says solve for y if x is 12. So we're just going to plug in the 12 and see what happens. So y equals 50,000 times 1.034 raised to the power of 12. Order of operations here, inside parentheses, but there's nothing to do. So we got to do the power and then multiply. So whip out a calculator. You got an answer? What you got? 7,468.2. That sounds reasonable. 7,468.2. Let's see. All right, so calculator-wise, here we've got, I think I can just type it straight away on this calculator. Yep, 1.034. There's the power button right there, raised to the 12th. Yep, and I would call it 2, 1 to the nearest. I would go to the 100th probably, but 2 is also an adequate answer. I will leave it there, that's good enough. All right, next. Here, the next part, we want to solve for x if y is equal to 63,000. So I've got 6,300, excuse me, equals 5,000 times 1.034, but this time I don't know what x is. So what do I have to do first to get x alone? But not a log yet, we're not quite ready for that. We can't do a log until the base is all by itself. Yeah, so we got to get rid of the 5,000 first, then we can do the log. So I got to divide by 5,000 so I can get the base alone. 1.26, thank you. And now I have the base alone, 1.034 to the power x. And then the routine we applied before to do this, based on a previous worksheet, is we take the log of each side. And the log is written on the left-hand side, like that. And the parentheses are a good idea. Whenever you have a log of a power, you can pull that power out. So now it's x times the log of 1.034. And that equals the log of 1.26. Now at this point, I wouldn't recommend plugging the log of 1.26 into your calculator yet, because then we'll have to round and we could compound rounding error. How do I break this multiplication right there? Yeah, divide by that whole thing, log of 1.034. It's just some number, it just looks weird. So now I'm ready to whip out my calculator and try and type this out. So that should be my x value right there. So I can remember it clear. I've got the log of 1.26 closed, divide by the log of 1.034. Did I get those numbers right? Sure. Equals 6.9-ish. So about 6.9. How could we check to see if that's right? Yeah, plug it back into the original and see what happens. What happens if we take, so for a check, after you solve an equation, just plug back in. What is 5,000 times 1.034 to the power 6.9? It should be about 6,300. So I'm just going to double check here. 5,000 times 1.034 raised to the power 6.9-ish. Calculator says, yeah, it's pretty close to 6,300. Okay, and we rounded. If we wanted the closer answer, we'd include more decimal points, 6.9 something. All right, not so bad. Let's do another one. Number 2. We decided this was the quadratic family. And first step is just to plug in. So we're going to drop a 6 in for the x. So 10 times 6 to the second power. So 6 squared is 36 times 10 is, I think, 360. Anyone else get that for y? The order of operations, okay. Now here we want to know when is y, what is x if y is 490? And so since 6 gave us 360, it's going to be something bigger than 6, right? So to solve that, I just write down y as 490 equals 10 to the x. And sometimes people like to write it backwards. If these guys are equal, it doesn't matter the order you write it in. You could say it's 10x squared equals 490. These two mean exactly the same thing, because equals doesn't matter whether you read it left or right. So I'm going to view it that way. What should I do first to get x alone? Yep, divide by 10 to break that multiplication. So now we've got x squared equals 49. And then what? Square root. And anytime we take the square root of a square, it kind of cancels if we put a plus or minus on the other side. And what's the square root of 49? 7, yeah. So it looks like x equals 7 or -7. Should work. And we can kind of see if we plug back in. If you square 7, you get 49. Multiply by 10, you get 490. If you square a negative number, you still get a positive 49. So either of those look pretty good by inspection. So I'm pretty happy with that. All right, linear. Ooh, slow down there. All right, so we got a couple of questions on this one. So as Emily pointed out, this is what we call linear. Because there's no powers on x or y, and there's no squares. They're just x and a y. So write this in slope-intercept form. So slope-intercept form is my favorite way to write these equations. That's the y equals m times x plus b. So basically what they're saying here is without picking an x value, we just want to solve the equation above for y. So if I'm going to solve this for y right here, what should I do first?
Minus 8x.
Yeah, get rid of that 8x. So we're going to subtract 8x on each side. Now, the trick there is on the left side, the 8x is gone, so I just have a 12y. And on the right side, these guys aren't like terms, so the best I can say is it's negative 8x minus 36. And I'm writing them in that order because I'm trying to match this order up here. Okay. You could call it, if you want, negative 36 minus 8x. But again, I'm trying to match that order up there. The last step would be to divide by 12. And the catch there is this whole side is divided by 12, which means both the negative 8x is going to be divided by 12 and the minus 36 is divided by 12. So now I have to clean that up. Let's see. Yeah, what number goes into both 8 and 12? 2 or 4. Yeah, so 4 goes into 8 twice, so that's going to be a -2. 4 goes into 12 3 times, so I get negative 2/3 times x is the way I'm going to write it. So what's my m here? It's the whole negative 2/3. Yes, the whole negative 2/3 is the m. So that's my m. And then my b, let's see, 12 goes into 36 3 times. So here's my equation, and just off to the side, I'm going to make a note. M, my slope, is negative 2/3, and B, that's called the y-intercept. We often call it the starting point. That would be negative 3. But this is what I was looking for right there, just to rewrite it in that way. The nice thing about writing it that way is now I can easily answer the second question. I can just plug in 6 there and see what happens. So if x equals 6, then y is going to be negative 2/3 times 6 minus 3. So I'm going to view that 6 as a 6/1. And remember, when you multiply fractions, you can reduce ahead of time. That's the only time you can do that. So I could here say 3 goes into 6 twice. 2 times 2 is 4, but that's a negative times a positive. So I think that cleans up to be negative 4. Does that look all right? And then minus 3, it looks like y is negative 7 there.
Now, for the test, do we have to put it in slope-intercept form like that?
Only if I asked to. Yeah, so if it says, hey, what's the slope-intercept form, then you want to do that. If it just said, here's the equation, plug in 6, you could just plug in 6 directly.
Okay.
Yeah, you wouldn't need to do that.
Question, if
Yeah.
we have our scriptures from last term, still can we use those?
Worksheets?
Yeah.
Yes, you can use any word. I don't think you'll need them because I'm really just going to pick questions from modules 3 and 4. But if you think they might help, sure, you can use last term's worksheets too. Yeah, I don't have a problem with that. All right, so next one we have to do is solve for x if y is 9. So where do you want to do that? Do you want to do it in the original equation or our new slope-intercept form? Which looks easier? Plug in the 9 in the red one or the original? What'd you say, Emily? The original? Okay, let's try it that way. Yeah, I think it's about the same in terms of difficulty. So 8x plus 12y equals negative 36. Or was it negative 8x? Yeah. It was just 8x, okay. So 8x plus 12y equals negative 36. I want to plug in y equals 9. All right, so dropping that in, I get 8x plus 12 times 9 equals negative 36. I got to figure out what 12 times 9 is. 108 on a good day, yep. Plus that 8x. All right, what should I do next now that I've cleaned that up? Minus that 108, beautiful. So that's going to give me 8x alone on one side, and then 8 and 6 is what? 144?
Yeah.
And negative, right? Yep. Divide 8 into that to break the multiplication. And let's see. Negative 18? Okay. We did it. All right, so now that we're hopefully nice and warmed up, I'm going to set you guys free to just attack these problems. And if you get stuck on something, let me know, and I will do my best to help you figure it out. Yes, correct. Nope, we didn't do it that way. So what we would do is we would just take however many miles I went and subtract the 30. So it would be $0.4 dollars. 0.4. And then times, let's say X is your line, so just call it X minus 30. Yeah, so first we take off the 30 miles they give us, then we multiply whatever's left by 40 cents, and then we add on $40. You walk Emily?
Yeah.
Did you get the cube okay? On your calculator? Okay. And Daisy, just text me or speak if you have a question you're stuck on. How's it going?
I think good.
Kicking back. The catch on that one is the 40 cents is just over the allowed mileage, and they allow up to 30. So they're only going to charge you 40 cents on any miles over 30. Over 30. Yeah. So what you have to do is take the 40 cents times X minus 30. Yeah. So there's an extra order of operation step there. So here's the way I would do that one.
So you could just take the 30 out of 40?
No, that's different. So if I let X be the miles, the first thing I want to do is figure out how many miles I went over 30. So maybe I went 80 miles. First I subtract 30 because they're giving me a free 30 miles. And then I have to multiply that by 40 cents per mile. So it says it's just the overage, they're charging me 40 cents per mile. Then I add on the flat fee of $40 a day. So that would be my cost right there. Yeah, it's a tricky one. What's that? Yeah, so then so if you went 50 miles, you plug it in, first you do is take off the 30 they gave you, 30 miles, and then the extra 20 miles, they're charging you 40 cents a mile. Plus they're charging you $40 no matter what. Right, so these are my dollar amounts. And these guys are miles. Yeah. Yeah, we're losing 10% per year. So if we're losing 10%, what's our multiplication factor? No, not times 0.1. That's the percent off. What are we left with? Yeah, so the multiplication factor would be 90%. That's the more important one. Yeah, so anytime you have a percent change, you got to add that to 100%. That's a negative 10%, so that leaves us 90% of the coral reefs remaining per year. Yeah, so it's the multiplication factor that's the bigger deal. It's always out of 100%.
Working on number 5. My formula is bad. I think we should work out. My equation is 1 equals out of time. That's not right. I shall work it out. Or work it out.
What'd you have for a formula? So what kind of equation is this going to be?
Exponential.
Yeah, it's definitely exponential.
My formula was,
Since we're given the growth rate there, and it's a negative, it's going to be 100% minus 10%. So 90%, or 0.9 is the important thing. So what do you get for the equation?
I had y equals 100 times the power of t.
Okay.
I think we
So
Yeah, because this is per year. Yeah, so that's right. That's good.
I go to figure it out. So
Yeah.
I put 50
So you want to know, so we put 50 in for y.
equals that.
Yeah. I'm with you. Okay, then what?
And then I should take 100 off both sides, so that's
Ah, that's the problem.
That's right.
How do you break multiplication?
But
Divide. Yeah, so it's dividing by 100. Yeah, so that's going to give us 0.5 equals 0.9 to the t, and now you can use your logs to finish it off. Yeah.
Doesn't say I want to. It was like 16. It's 6.57, which is actually.
breakers.
Whoa.
I'm gonna take a test at 8 a.m. on Monday, so I can go home and crawl in bed, cry all day.
It won't be that bad. All right, so we're coming down to the end of our time. So somebody asked about the Emily asked about the final exam, and you guys get to vote off questions on the midterm. So yeah, I'm up for that again. So what you need to do, let me get to that page here. Is go check out the practice final exam. Right now there are 20 questions in there. I need to cut that in half. And based on last year, I had 2 different versions. One version, I got it down to 13 questions. The other one, I got it down to 5. You don't want a 5-question final. That means each question's worth a ton of points. That's not a good. We want something in the middle. So I think 10 is a good thing to aim at. So what I'd like you to do is send me an email and tell me which numbers you want to go away. You can pick 10 questions. State them in the order that you most want them to go away. So the first one is the one you least want to see on the final, and then go down from there. Okay? So check them out. Get me in. I'll need that by Thursday. So take a look at it over the next 2 days, and then send me an email saying number 1, number 7, number 8, whatever questions. You got to take a look at it and decide. And then I'll look at all the results and decide which ones to get rid of.
You want us to finish that?
The
4-7.
Yeah, work on 4-7. We'll have some time in class to work on it tomorrow. And so otherwise, the next 2 days are finishing up 4-7 problems and going over problems from the practice final. And then, cool. Don't forget to correct your test. And I'll get yours to you back tomorrow.
All right, sweet.